Welcome to TNT Wicked Trick series, and today we will be discussing about the relation between hybridization, geometry and bond angle of compounds. So first let's start with number of hybrid orbitals. As I had discussed in earlier videos of hybridization about finding number of hybrid orbitals, and from hybrid orbitals you can find hybridization, geometry and then bond angle of simpler elements where there is no lone pair. Okay, let's see. When the hybridization of hybrid orbital comes to, it will be sp2 hybridized, linear geometry and 180 degree. 3 hybrid orbitals sp2 hybridization, triangular geometry and bond angle 120 degree. When the hybrid orbitals 4 sp3 hybridization, tetrahedral geometry 109 degree 28 minutes bond angle. When it will be 5 number of hybrid orbital 5 sp3d hybridization, trigonal bipyramidal geometry 120 and 90 degree bond angles. Number of hybrid orbital 6 hybridization sp3d2 square bipyramidal geometry and bond angle 90 degree. When the number of hybrid orbitals is 7 hybridization sp3d3 pentagonal bipyramidal 90 degree and 92 degree and 72 degree bond angle. You can take a screenshot of this diagram and then learn by heart, because you must learn this much related to when there is no lone pair cases. Okay, let's take an example for each of these finding geometry. I'll take CO2. You can say finding number of hybrid orbitals. Formula is b plus m minus c plus a by 2. You can find the description in the link to in my other video of this full form of these abbreviations. Now valence electrons in carbon atomic numbers 6, 2 plus 4 valence electron. It is not a monovalent atom, so 4 number of no number of cations and anions, so divided by 2 it will be 2. That means sp hybridized, which will have linear geometry, as there are no number of, as let's see, carbon, oxygen. Valence electrons 1, 2, 3 are fulfilled in sharing with oxygens, so here will be no lone pair. These are for no lone pair cases. Now BF3, B atomic number 5, 2 plus 3, so it will be 3 monovalent atom plus BF3 monovalent atom 3 by 2 is equals to, because 6 by 2 is equals to 3. This means sp2. Bond angle 120 degree, triangular geometry, no lone pair because 3 are fulfilled here. BF F. Central atom has 3 electrons and each are used up in sharing. Central atom have 3 electrons which are used up in sharing. Now CH4, carbon outermost valence electron 4 plus monovalent atom 4 by 2 means 8 by 2 gives 4 means sp3 here. Tetrahedral geometry 109 degree 28 minutes. As in case of carbon, there are 4 electrons and 4 are used up in sharing with hydrogen, so no lone pair. In this way you can find where there is no lone pair and where there is no lone pair using this diagram as discussed earlier. So now we'll be discussing about lone pair cases, and the formula for lone pair cases goes like this: bond pair, lone pair. Bond pair 2 1 2 2 3 1 3 2 4 1 4 2 5 1. Two one, number of bond pair 2, lone pair 1. Well, 2 1. Now we will be talking about geometry. When bond pair is 2, lone pair 1, bend geometry, bend or angular. 2 2 also bent. 3 1, trigonal, pyramidal. 3 2, T-shaped. 4 1, seesaw shaped. 4 2, square planar. 5 1, square pyramidal. 2 1, bent. 2 2, bent. 3 1, trigonal, pyramidal. 3 2, T-shaped. 4 1, seesaw shaped. 4 2, square planar. 5 1, square pyramidal. So the main thing is how to find the number of bond pairs and lone pairs. So let's discuss a compound H2O. Well, if you see oxygen, here one sharing and here also one sharing, but the valence electrons is 6. 1 2 3 4 5 6. So the number of lone pairs is 2 1 2. Lone pair is equals to 2, bond pair is equals to to 2, because one bond pair here and another bond pair here. So lone pair 2, bond pair 2, it will be bent. Geometry will be bent geometry. Now let's discuss on NH3. NH3, nitrogen, hydrogen, hydrogen, hydrogen. Nitrogen has 5 electrons in outermost electron. 1 2 3 4 5. So bond pair is equals to 1 2 3, 3 bond pairs, and lone pair is equals to 1, which is this. So 3 1, trigonal, pyramidal shape, trigonal, pyramidal, trigonal bipyramidal. Trigonal pyramidal. Now let's discuss on a bit difficult XeFO. We know xenon is noble gas and fluorine has one left to complete its octet. So xenon, fluorine, 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 fluorine. Okay, fluorine, 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 fluorine. Xenon has 8 electrons. 1 2 3 4. Now let's 3 dot 5 6. 1 2 3 4 5 6 7 8. Now bond pair is equals to 1 2 3 4. 4 bond pairs. Lone pair means 1 and 2 lone pairs. This means 4 2 square planar. Shape is square planar. Yes, in this way you can find where there is lone pair cases. Now one thing you must remember, that is XeF2 and I3 minus as linear shape. Mostly asked I3 minus which has linear shape. So these two compounds have linear shape, you must remember that. Now talking finally about bond angle. Bond angle in lone pair cases generally is not asked to find the exact, but it is mainly asked to find out the order. As three compounds are given and find the and arrange them in the occurrence of bond order angle. So the easy trick I think the most easy trick is that one lone pair decreases bond angle by 2 degree. That means when there is one lone pair, bond angle decreases by 2 degree. Let's take an example. NH3. Now finding hybridization. Nitrogen has 5 electrons plus 3. 8 by 2 means 8 by 2 4. 4 means sp3 hybridized. We know that sp3 hybridized has bond angle 109 degree 28 minute. This is the bond angle for sp3. But as we know that hydrogen and 1, 2, 3, 4 and 5 there is one lone pair, so it decreases by 2 degree. It will be about 107 degree. Now mainly the question comes like comparing three molecules like NH3, like compare between NH3, CH4 and H2. I'll be showing you first NH3 which comes on about 107 degree. CH4 means 4 plus 4 by 2, that will also come 4. sp3 109 degree 28 minute. But making the number of electrons in the valence shell of carbon is 4, 1, 2, 3, 4 and it is completely hybridized, so no lone pair, same angle 109 degree 28 minute. Now finally on water. H2O. Water, oxygen has 6 in outermost shell plus 2, 8 by 2 means 4. 4 is also sp3. It will give 109 degree 28 minutes. But oxygen has lone pair as oxygen, hydrogen 1, 2, 3, 4, 5, 6. 2 lone pairs. So 2 lone pair means decrease by 4 degree. It will be about 105 degree. So maximum bond angle in CH4 and then in NH3 and finally on H2O. This is the required bond angle order of given questions. If we had to discuss on bond angle, it decreases by PLS @PLS. So P means peripheral atomic size. L means lone pair. 2 degree on one lone pair as discussed just now. And then S means size of central atom. When the peripheral atomic size is more, bond angle decreases. When the size of central atom is more, bond angle decreases. And when there is number of lone pair, bond angle decreases. So this is decreases case, bond angle decreases by PLS. So now let's talk about peripheral atomic size. Let's take an example of PCl3, PBr3, Pi3. Well, the number of atomic size in of iodine is maximum as your principal element phosphorus is same. So I3 will have peripheral atomic size more, less bond energy than boron. But there is an exception with PF3 and it will be at the last, although it has smallest peripheral atom. So now talking about size of central atom. H2O, H2S, H2SE and then H2TE. The size of central atom is smallest, a bit big and the largest. So where the number of size of central atom is largest, it will have least bond angle. So it will have least, and then this is the required answer. In this way you can find bond angle orders of different elements. Keep tuned for more videos. Thank you.